Good morning, afternoon, or evening, cats and dogs. Today's video comes from the lesson 8.4 guided notes on volume of prisms. We'll start with rectangular prisms, which are the easiest to find the volume of, and then we'll move into triangular prisms and other types of prisms as well. The volume of a shape measures the space inside of a three-dimensional figure, so it's kind of like the area of a three-dimensional shape. So again, the amount of space inside a three-dimensional figure. A really good example would be if you're filling a container with liquid. If you have a soda bottle, for example, the volume is the amount of soda that's inside that bottle. Anytime you're working with science experiments, a lot of times you're working with volume. So for the volume of prisms, the formula that we utilize for any prism is volume equals capital B times H. So the volume of any prism is equal to the area of the base times the height. Capital B is different than lowercase b. Sometimes in math, it's also important to differentiate between capital letters and lowercase letters. In this case, and for our purposes in this unit, capital B is going to stand for or refer to the area of the base. That's really important for us. Lowercase b is just going to stand for the length of the base of a two-dimensional shape, whereas again, capital B represents the area of the base. So if we're looking at a rectangular prism, the base is a rectangle. In fact, I'll outline the base of this rectangular prism right here. And the area of this rectangle is length times width, and then we multiply it by the height of the prism, which is h. So the volume of any rectangular prism, and this formula is on your formula sheet, is length times width times height. So the volume of any rectangular prism, it has to be a rectangular prism or box, is length times width times height. For a polygonal prism, which is anything except a rectangular prism, although you could use this for a rectangular prism as well, we have a simpler version, again, the length times width times height. But for any other prism that is not a rectangular prism, you're going to see the formula capital V equals capital BW on your formula sheet. Again, capital B represents the area of the base. W, I don't love the usage of that. I'd rather use H, but this is what the formula sheet uses. W is the width or height of the prism. It's the distance between the two parallel bases. That's really important for us. This part is not on your formula sheet, but the picture is given, so that should help you determine what W stands for. And again, capital B, I'm going to stress this many times, represents the area of the base. Now, the formula for the volume of a cube, this might be on your formula sheet. I don't have it right in front of me right now, but it's s to the third power, since every side of the cube has length s, kind of like when we did squares, but that would be s times s. This is s times s times s, which is s to the third power. We will take some time in class and show you where your exponent key is again and how to plug in something to the third power. You can also use the length times width times height formula. It also works since a cube is a rectangular prism. All right, let's go into our exercise problems. Beginning with number 1, we're given a rectangular prism. The first thing that's important to do is identify what shape we're talking about. It's a rectangular prism, so the formula we can use is just length times width times height. Does it matter which one's your length, width, or height? It doesn't. You're just going to multiply them. So I took 4 times 3 times 6. Feel free to use the dot for multiplication. However, sometimes we have decimals as our length, width, or height, so that can get confused with the multiplication sign. 4 times 3 times 6 is going to get us a volume of 72 centimeters cubed. 72 centimeters to the third power. Kind of like for area, we had centimeters squared. When we did perimeter, it was just centimeters. For volume, it's going to be centimeters to the third power, because 72 centimeters cubed represents how many cubes of 1 centimeter on each side we can fit inside of this rectangular prism. And in fact, we could fit 72 inside of this rectangular prism that we have. All right, let's take a look at number 2. Also a rectangular prism, but it's also a cube since all the sides are the same length. So I used s to the third power, which is 2.5 to the third power, and that gets us 15.625 inches cubed. Don't forget your labels. If you don't know how to plug in 2.5 to the third power on your calculator, definitely check in with me. But you can also do 2.5 times 2.5 times 2.5. So you can just multiply it that way, not 2.5 times 3, so be careful. Don't round your answers either. Sometimes I get asked by students, should I round it? It's a short enough decimal. Just write the whole thing. All right, let's move right ahead to number 3. Number 3 is also a rectangular prism. So we're just going to do length times width times height. Take 6 times 1.9 times 10. Here's a great example of where the parentheses are good for multiplication because 1.9 is a decimal. This is going to get us 114 millimeters cubed. So final answer, 114 millimeters cubed. Now, I do want to look at a triangular prism because if we go back here, you might notice, again, for rectangular prisms, we have a very specific formula. For any other prism, so often students will say, well, I don't have a formula for the volume of a triangular prism. You do. It's a polygonal prism. It's capital B times W. So you're going to notice that I used V equals capital B times W. I'm going to highlight that in yellow here. This is a great example before we get into our other problems. The first thing I need to do is find the area of the base. It's called a triangular prism, so the bases are triangles. So I'm going to highlight my two bases in yellow. That's these two guys right here. And the base and height of your, or sorry, I guess I shouldn't go with base and height of the triangle yet. But if we want to find the area of the base, you can see that I did that over here. The base is a triangle, so I need to use the formula for the area of a triangle because I'm finding the area of a triangular base. If my base were a different shape, let's say it were a trapezoid, or I'm trying to think of another example of a shape we worked with, maybe a parallelogram or something like that, we would find the area of the base using the area formula for that shape. So we'll do half times base times height here. The base and height of this triangular base meet at a right angle. We see that right here that I highlighted in yellow. So the base and height are 4.1 and 3.2. We'll do half times 3.2 times 4.1 is 6.56 inches squared. Notice how it's inches squared since it's just the area of the base. We don't have to multiply it by 2 since there are two bases. That's taken into account in our formula. We just plug this area of the base that we got. I'm going to highlight it in green. We just plug it in for capital B, and then we multiply by W, the width of the prism. That's the distance between your two parallel bases. That will be 8. So you notice there is an extra number here that we did not need to use, the 5.2, since it's neither the base or height of the triangular base, and it's also not the width of this prism. So 6.56 times 8 gives us a volume of 52.48 inches cubed. These triangular prisms are tough, so pay close attention as we go to do these. So number 4 is a triangular prism as well. So we're going to use the formula V equals capital BW. You can see that way at the bottom here. First thing I'm going to do is find the area of the base. The base is a triangle. In fact, let me highlight our two bases in yellow. So it's going to be this guy right here and this guy right here. Oh, sorry about that. There we go. Since the bases are triangles, we're going to find the area by doing half times lowercase b times h. Again, lowercase b represents the base of the triangular base. Kind of confusing, right? So our base and height have to meet at a 90-degree angle. In fact, I see a 90-degree angle right here. So my base and height of my triangular base will be 9.8 and 5. So I'm going to highlight those numbers because we're going to use those in this formula. So we're going to do half times 9.8 times 5. That's going to get us an area of the base of 24.5 meters squared. And again, that's the area of the triangular base. So we're going to replace capital B with 24.5. W represents the distance between your two bases. That will be 4. We do not need to use the 11 meters at all. It looks really similar to this example in the box over here. So we're going to do, let me slide this down. We're going to do the 24.5 times 4, and that's going to get us a volume of 98 meters cubed. Again, first thing you want to do is identify the shape of the base. If it's a triangle, use the formula for the area of a triangle, which is also on your formula sheet. Find the area of the base, identifying base and height of the triangular base. Replace capital B with that area, and then multiply by the width, the distance between your two bases. Let's try another one. All right, number 5. So another triangular prism here. We identified three-dimensional shapes last unit. So we're going to use capital B times W again, since it's not a rectangular prism. Let's start by finding the area of the base. Our bases are triangles. I realize that it's sitting on a rectangle, but remember, it's called a triangular prism for a reason, so the bases will be triangles. So let me go ahead and outline those bases in yellow for us. The base and height have to intersect at a 90-degree angle, and I do indeed see a 90-degree angle right down here. So the base and height of my triangular base will be 26 and 28. So I'll do half times 26 times 28. The area of the base is going to be 364 meters squared. Don't worry about the label here. Your final answer should have a label. I just like to put that on there to show you that it is the area of a two-dimensional shape, the area of each of these triangles here. So we're going to replace B with 364. W is the distance between your two bases. That will be 41, which means I do not need to use the 38.2. So we are going to do 364 times 41. Volume of this triangular prism is 14,924 meters cubed. All right, let's give our last one here a try of triangular prisms. So this is again a triangular prism, and our bases I'm going to go ahead and highlight in yellow. So this is going to be one of my triangular bases. And back in the back is going to be my other triangular base. Sorry, let me slide this down so my record button is over there. I don't want to hit the record button to stop recording. So my two triangular bases here, again, we're going to do capital B times W. But let's find the area of the base first. So that's this work right here. That's half times base times height. The base and height have to meet at a 90-degree angle, which I see here. So 8 is going to represent the base of my triangular base. 4 is going to represent the height of my triangular base. So I am going to do half times 8 times 4 to find the area of my triangular base. That's going to get me 16 centimeters squared. And again, that's for the area of the base. Now the width of this thing is the number we haven't used. It's the distance between your two triangular bases. That will be 15. So we'll do 16 times 15 to get our final volume. That's going to be 240 centimeters cubed. Again, these triangular prisms are a little bit more challenging. We'll need some practice with this, which of course we'll get in class. All right, so number 7 is an octagonal prism, I believe. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we've got an octagon on the top. We've got an octagon on the bottom. They're parallel to each other. So this is an octagonal prism, which is also considered a polygonal prism. So the volume formula we're going to use is capital B times W. Capital B represents the area of the base. Well, we're given the area of the base. We don't know how to find the area of an octagon. Thank goodness we're given the area of the base to be 45. The width of this thing is the distance between your two bases, which will be 2.8. So we are going to do 45 times 2.8 to get our volume, and we'll get 126 meters cubed. So it's actually easier than your triangular prisms because we're giving you the area of the base. If it's a shape that we're not familiar with finding the area of, we'll make sure to give you the area of that base. All right, number 8 is a pentagonal prism. So we have two parallel pentagons. They give us the area of the base here, and I'm going to highlight that in green. That's going to be our capital B. That's 125. W is the distance between your two pentagons, which is going to be 6. So we are going to do 125 times 6. Our volume will be 750 centimeters cubed. Pretty straightforward there. All right, let's take a look at some word problems, still from the set of guided notes. Let's look at number 9. An aquarium is being constructed so that it will be a rectangular prism with a length of 8 feet and a width of 5 feet. If the aquarium is to hold 220 cubic feet of water, what should be the height of the aquarium? Again, we don't have flashing lights here saying, hey, this is a volume question, but we know we're talking about the aquarium that's a rectangular prism, so we know it's a three-dimensional shape. We know that it has a length of 8 feet. We always want to identify that information we're given, a width of 5 feet. And we know that this aquarium is going to hold 220 cubic feet. That right there represents the volume. Let me get better text here. There we go. So that's going to represent the volume of this rectangular prism. It's how much water this thing is holding. And we want to find the height. So what should the height of the aquarium be? Oops, not a very straight line there. There we go. So let's use our volume formula for a rectangular prism. Again, we know it has to be volume or surface area. We haven't talked about surface area because it's a three-dimensional shape, and because we're talking about how much liquid this is going to hold, we're talking about volume, space inside. Our formula is volume equals length times width times height. Replace V with 220, replace L with 8, W with 5, and let's solve for H. First thing I would do is do 8 times 5 and figure out what that is. 8 times 5 is going to get us 40. So we get 220 equals 40H. Solve this one-step equation. We'll divide both sides by 40, and we get a height of 5 feet. So this is a really big aquarium. Kind of like when you go to like Bass Pro Shops, for example, they have those huge aquariums in there with lots of fish. All right, let's take a look at question number 10. A children's rectangular pool holds 960 cubic feet of water. What is the depth of the pool if the length is 30 feet and the width is 16 feet? So we're talking about a rectangular pool, which is in 3 dimensions. A 2-dimensional pool would be kind of weird, right? So we've got a 3-dimensional rectangular prism here for our pool. We know that it holds 960 cubic feet of water. We're talking about cubic feet, which tells us its volume, but also we're talking about how much liquid this is going to hold. So that indicates volume for us again, and our volume is specifically 960 cubic feet. So we'll replace V with 960. We're also given that the length is 30 feet, the width is 16 feet. And we're trying to find the depth of the pool. Now that's going to represent like the height of the pool. So even though it uses the word depth, we're finding H. So same formula from the last question. Replace V with 960, L with 30, W with 16, and let's solve for H. So the first thing I want to do is do 30 times 16. So I have 960 equals 480H. Divide both sides by 480. And the height or depth of this pool will be 2 feet. Keep in mind it's a children's pool, so it's not going to be super deep, which is why we get a pretty small number there. All right, let's move right ahead and take a look at number 11. A mini fridge has a volume of 9,504 cubic inches. It measures 45 inches high by 22 inches wide. Find the depth of the mini fridge in inches. Actually just ordered a mini fridge for our basement to keep next to like our workout equipment. So pretty similar dimensions, I think, although this might be a little bit bigger than the one we got. So we're talking about the mini fridge, which generally they're going to be the shape of a rectangular prism. You're going to notice all these were rectangular prisms for the word problems. That makes sense. We're trying to keep it relatively simple for you. I'm not giving you any solve for the height of the triangular prism or anything like that. So this is about as difficult as these word problems for volume are going to get, at least for this lesson here. We know it has a volume of 9,504 cubic inches, and it's straightforward there. It tells you we're talking about volume. We have a height of 45 inches and a width of 22 inches. For this one, we need to find the depth. So basically just the missing value, which we can consider the length. Since we have the height and the width, it doesn't really matter. But we're going to assume this is a rectangular prism shape because we're given both the height and the width. We need to find our missing value here. So let's replace V with 9,504. That's the volume as given. We're going to leave L as it is. Again, it doesn't really matter which variable you solve for here, as long as it's either length, width, or height and not the volume. Our width we're going to replace with 22. Our height we're going to replace with 45. So the first thing I did was 22 times 45. So that gets me 9,504 equals 990 L. Divide both sides by 990. And the length, or again, if you want to consider it the depth of this mini fridge, will be 9.6 inches. That's a really narrow mini fridge. We've got 9.6 inches here. I think ours is definitely deeper than that. All right, number 12, our last question, which is a multiple choice problem. I added this a few years ago because it's really similar to the question that's on your test. So let's take a look at it. A rectangular prism has a volume of 5,280 cubic inches. It has a height of 4 inches. Which of the following could be possible dimensions of the base? Well, we know we're talking about a rectangular prism here, and we're given the volume of 5,280 cubic inches. We do know that it has a height of 4 inches. So the formula that we would use is V equals length times width times height. Let's replace V with 5,280 and the height with 4. And let's divide both sides by 4. 5,280 divided by 4 is going to get us 1,320. Now, unfortunately, that doesn't tell us either of the dimensions, but what it does tell us is that the length times width, the dimensions of your base, have to multiply to give you 1,320. So what I would do is I would go into these 4 answer choices, and I would grab my calculator, which I'm doing right now, and I would take in letter or choice A, I would take 4 times 1,320, which is clearly not going to get me 1,320. So that means I can eliminate choice A. Let's go to choice B. We've got to take 44 times 30. That gets me 1,320. So that tells me that those could be dimensions of the base of this rectangular prism. I'm just going to do C and D just to prove that those are not going to be dimensions of the base. So in letter C, if I do 40 times 132, it gets me 5,280. I need that product to be 1,320, so C does not work. And then D, if I take 40 times 50, that's going to get me 2,000. And again, I need 1,320, so I can eliminate choice D as well. So B has to be our solution here, since 44 times 30 gets us 1,320. All right, so volume is pretty straightforward, especially for rectangular prisms. Triangular prisms or other polygonal prisms, a little bit more difficult. But you can see that the word problems for this, they're not too bad because they just involve that formula, capital V equals length times width times height. We'll, of course, see some more practice problems in class as well. Thanks for listening.